So the last time we were in the middle of discussing the green aspects of aldol reaction. We had already discussed the reaction in presence of surfactant, reactions in ionic liquids, reaction in presence of only water, or in presence of a mild Lewis acid. And we have also discussed why these reactions or modifications of the existing aldol procedures, why are these considered to be environmentally more friendly, more sustainable approach? Why are these called the so-called green methods? So here we carry on with our discussion, and this time this is a reaction in solid phase. The obvious advantage of a solid phase reaction is surely the absence of organic solvents, and organic solvents are generally useful in carrying out reactions because they bring the 2 or 3 reactants together, but at the same time most of them are not biodegradable, and their disposal in the environment creates a problem of chemical pollution. Therefore, if we could do reactions without using any sort of solvents, we can get rid of that problem that arises out of using excess solvents. So people have directed their efforts in trying to carrying out many organic reactions in absence of solvents, and one way obviously to do that is to carry out the reaction in solid phase. If one of the reagents or the substrate or the reactants is a liquid, then your job is sometimes easy, because maybe the reactant itself will act as a solvent, that liquid reactant. But here we are using two partners who will take part in aldol addition and subsequently aldol condensation, where both reactants are solid, and therefore there is no other way to do the reaction except in solid phase. And you are not completely alien to that concept. You have yourself done one solid phase reaction, and that will be again done in the practical of this paper, and that was the benzylic acid rearrangement, where you mixed a certain amount of benzyl with a certain amount of potassium hydroxide pellet in a mortar, and you made a mixture, powdery mixture out of it with the help of a pestle, and very quickly it was that powdered mixture was transferred into a round bottom flask, and that round bottom flask was stoppered with some cotton, and it was placed in a water bath for about half an hour to 45 minutes or 1 hour, and then you worked it up with some amount of water, and then subsequently after filtration you acidified the filtrate and you got the benzylic acid product. So that was a reaction that you yourself did, and that was a solid state reaction. So people have explored that avenue as well, and see here they have used 4-phenyl cyclohexanone, and they are combining it with an aromatic ketone which has alpha hydrogen here, and that hydrogen is acidic. So this compound is mixed with the 4-phenyl cyclohexanone, and it was ground at room temperature. 98% yield was obtained. See how this thing works? So that's an aldol reaction which was done in solid phase. The same thing was done for vanillin. চিনতে পারছো vanillin কে? This one is vanillin, right? ভ্যানিলিনের স্পেকট্রাম আগের সেমিস্টারে করেছো না? ভ্যানিলিনের স্পেকট্রাম ছিল তো, আইআর এনএমআর। তো ভ্যানিলিনের স্পেকট্রাম প্র্যাকটিক্যালে ছিল। দিস ইজ ভ্যানিলিন, দিস ইজ অ্যালডিহাইড. So this is a cross aldol reaction where the aromatic aldehyde does not have any alpha hydrogen, and also আমরা আগের দিন ক্রস অ্যালডলের কন্ডিশনসগুলো বলার সময় বলেছিলাম যে couple of conditions has to be met. One is that the one of the components should not have any alpha hydrogen, so that condition is met here, and that component which does not have the alpha hydrogen should be more electrophilic than the component which has alpha hydrogen. So this one is like keto, you know, keto, right? And this one is aldehyde. So which one is more reactive? Which one is more reactive? Towards nucleophilic addition, a ketone or an aldehyde? Which one is more reactive? Don't you remember? Nucleophilic addition depends upon the steric crowding. If the carbonyl has bulky groups around it, then its electrophilicity is less. So aldehydes are definitely more reactive because hydrogen steric crowding or hydrogen steric size is much lower compared to any alkyl groups or any aryl groups. And also, unlike aryl groups or alkyl groups, hydrogen is not known for donating electrons towards the carbonyl carbon. Therefore the aldehyde carbon is much more electrophilic. বোঝা যাচ্ছে কথাগুলো? বোঝা যাচ্ছে তো? বুঝতে পারছো না? বোঝা যাচ্ছে না? ঠিক আছে তো? So you have this cross condensation, the yield is 77%. Okay. In absence of solvents, some aldol reactions are in fact found to be more efficient compared to when you do those things in solvent. Say for example, you have taken this ketone. এই কিটোনটার নাম বলতে পারবে? এর নাম কি? What is the name of this ketone? Acetophenone, right? That's acetophenone. Does it have alpha hydrogen? Yeah, sure, it has alpha hydrogen. The alpha hydrogen is here. As you can see, the alpha hydrogen is here. There are 3 alpha hydrogens. We are concerned about one. So this is one aromatic ketone which is condensing with an aldehyde. The aldehyde itself, as you know, there is no alpha hydrogen here, but the CHO group itself is more reactive than the carbonyl, ketocarbonyl, the aromatic ketone, and therefore this is an ideal combination for your cross aldol reaction. So you do this thing in presence of solid NaOH, and you take the requisite amount of aldehyde and the ketone in a mortar, and you add the NaOH pellets there, and you ground it at a very fine powdery mixture, and then you work it up. Within 5 minutes the yield of the reaction is 97%. The product that is formed is an alpha beta unsaturated aromatic ketone, and that's also known as a chalcone, right? Okay, here is a little bit complicated example. Here this is an enolate which is derived from an S star. Can you see that this is an enolate that is derived from S star? এটা দেখে বুঝতে পারছো যে এটা লিথিয়াম এনোলেট একটা, এবং এটা এসেছে একটা S star থেকে। কোন S star থেকে এসেছে বুঝতে পারছো? So let me jog your memory for you. Okay, here we have the thing itself. এইটা হচ্ছে আমার enolate, right? তো এইটা কোথা থেকে এসেছে বুঝতে পারছো? It is coming from this one, না? এই হাইড্রোজেনটা ছিল, this is the alpha hydrogen, this hydrogen is the alpha hydrogen, red hydrogen. ক্যামেরা দেখা যাচ্ছে? ক্যানভাসটা দেখা যাচ্ছে? তো এই হাইড্রোজেনটাকে খেয়ে নিয়েছে, খেয়ে নিয়ে এই এনোলেটটা তৈরি করেছে। তাহলে এই জিনিসটা কোন অ্যাসিডের এস্টার? তো এর অ্যাসিডের এস্টার নিশ্চয়ই। এর নাম কি? এই অ্যাসিডটার নাম কি? 1, 2, 3 4. So that's a butanoic acid. 1 2 3 4, 1 2 3 4, because this is the UPAC number 1. So 3 position e duto methyl ache. So this is a 2,2 dimethyl butanoic acid, right? Tar methyl ester, and that is why you call this thing methyl 3,3 dimethyl butanoate. Clear?
Yes, sir.
Any problems? No. Okay. So they have mixed it with an aromatic aldehyde. Aromatic aldehyde 2-methoxyphenyl, অর্থাৎ এই R গ্রুপটা 2-methoxyphenyl হতে পারে, 4-chlorophenyl হতে পারে, 4-nitrophenyl হতে পারে. They have done all sorts of variations by putting electron releasing groups like methoxy, by putting electron withdrawing groups like nitro, by putting chameleon groups like chloro, and they have done this thing in absence of any solvent in solid phase. Under vacuum they kept it for 3 days at room temperature, and when this addition reaction will take place, then there will be 2 stereo centers on your product. I have written that thing in a zigzag form where these tertiary butyl and OH groups are on the same side in the zigzag projection formula. We call those the scene product. Eta scene to? Eta scene 90?
Scene, sir.
Okay. And if they are on the other side, then these are called the anti-product. I have a question. Are these the only products here? এই দুটো প্রোডাক্টই হবে না আর কিছু হতে পারে? Is this the only scene product that can occur? না আর কিছু হতে পারে? Let me rephrase this question. Is this thing chiral? এটা কি chiral? Can you spot any symmetry element here? Any sort of second kind sigma plane or I? Nothing. So this is chiral, no? So আমি যদি এর মিরর ইমেজটা নিই, তো মিরর ইমেজটা এরকম হবে না? দেখো তো। সেটাকে তুমি কি বলবে, সিন না অ্যান্টি কি বলবে? হোয়াট আর ইউ গোয়িং টু কল ইট? সিন. সো সিন দুটো হবে, আবার অ্যাট দ্য সেম টাইম you will also get another anti, right? You will also get another anti like this. এটাও হবে এরকম and এটাও হবে এরকম, right? So the reaction is diastereoselective, of course, because the two diastereoisomers, syn এবং anti, they are diastereoisomers, but those are enantiomers, right? In absence of any sort of additional chirality, you will be getting a racemic mixture, but syn may dominate or anti may dominate depending upon the model that you are going to use. এই ধরনের রিয়াকশন করার সময় আমরা অনেক সময় সিন বেশি পেয়ে থাকি, কখনো অ্যান্টি বেশি পেয়ে থাকি, দ্যাট ডিপেন্ডস যে কোনটা আসবে না আসবে, সেগুলো আমাদের মডেলিং করে করে হয়তো দেখতে হবে। বাট দ্য ফ্যাক্ট রিমেন্স দ্যাট the reaction is diastereoselective, and in the solid phase the diastereoselectivity is pretty high. 8:92 mixture of the syn and anti products. The yield, overall yield is 70%, but this one is 92% and this one is only 8%. So that's a diastereoselective reaction which you can do in solid phase. And as usual, after discussing maybe 2-3 examples of this, we have to highlight why this is a green concept, why these reactions are considered to be green. First of all, this is a solid phase reaction, therefore hazardous solvents, use of hazardous solvents has been avoided. Generally the reaction time is much lower compared to the thing that you are doing in aqueous phase or any organic phase, because the rate of the reaction is very high, and yield is acceptable or very good. Sometimes the yield is as high as 99%, and product isolation is easy because side product formation is less. If you remember the last class, these are the common themes, that the yield is high, the time is low, the reaction is energy efficient, etc., etc. product isolation is easy. Those 2-3 points are occurring almost everywhere. The additional point that you are seeing here, যেখানে hazardous solvent we can avoid because this is a solid phase reaction. The next technique that we are going to discuss is the microwave irradiation of aldol, using microwave irradiation in achieving an aldol reaction. So an aromatic aldehyde like this and an aryl methyl ketone like that, they can be heated in microwave in presence of a base catalyst or even an acid catalyst, and within very short time, because we have already discussed microwave effect and how it affects the rate of the reactions, within very few minutes or very few seconds in some cases, almost 90 to 100% yield you can get of the corresponding chalcone type derivative. One particular example here we are demonstrating. In 100% yield, the product which is known as the jasmine aldehyde is generated in presence of potassium hydroxide within microwave. The reaction is being assisted by a phase transfer catalyst, the identity of which I could not find. So this is the benzaldehyde, which is the electrophile, and this is the 1 2 3 4 5 6 7 heptanal, which is the nucleophile. A cross condensation reaction is happening where enolate from here is attacking at this place, and we are getting the cross condensation product. So microwave reactions are over within, say, maybe 1 minute, only in 1 minute or maybe 2 minutes or maybe a few seconds. So that is a tremendous aspect, that you save a lot of man hour and you also save a lot of energy output. So that's very efficient reaction. That is one green context. Sometimes the product yield is as high as 100%, so it's a very efficient reaction. Side product formation is low, yield is high, and therefore product isolation is easy because polycondensation and etc. other reactions are not happening. So that's the green context. So this brings us to the end of the discussion of aldol condensation. Do you have any questions on this? Anybody has any questions? If you have, you can ask me, or if you think of something which may not be clear to you when you were reading this stuff or listening back to this lecture, you can always come to me and talk about this. So the next name reaction that we have in our syllabus is the Cannizzaro reaction, which is also known as Cannizzaro disproportionation. Now disproportionation reactions are those reactions where one of the reactant is getting oxidized and the other is in turn getting reduced, and the same reactant. So aldol condensation and Cannizzaro reactions are complementary to each other in the sense that the carbonyl compounds that have alpha hydrogen, they tend to undergo aldol condensation by forming an enolate, and then that enolate is acting as a nucleophile and attacking another carbonyl which is acting as an electrophile. But aldehydes, particularly aromatic aldehydes which lack alpha hydrogen, they tend to undergo another reaction. And for that matter, any aldehyde which lacks alpha hydrogen is capable of doing this, like formaldehyde, or say if you have a 2,2-dimethyl propanol, or benzaldehyde, or any substituted benzaldehyde. These aldehydes tend to undergo a separate reaction. The reaction condition of Cannizzaro reaction and aldol is quite similar. You can do aldol reaction in either acid or in base, and in presence of strong base, this type of aldehyde compounds, they undergo the Cannizzaro reaction. This reaction was discovered by Stanislav Cannizzaro, after whom this reaction is named, and the outcome is a disproportionation where an aldehyde with no alpha hydrogen, one molecule gets oxidized to the corresponding carboxylic acid salt. It has to be a salt because under the strong alkali that we are using here, the molecule cannot exist as a free acid. It will have to be a sodium or potassium salt depending upon the alkali that you are using, and other molecule gets reduced to a primary alcohol. I suppose you remember this. Cannizzaro in 1853 demonstrated this reaction first, where he converted a benzaldehyde into a mixture of potassium benzoate and benzyl alcohol, which is also known as phenyl methanol, by refluxing the benzaldehyde in potassium carbonate, where one molecule of benzaldehyde is oxidized to the benzoate salt and the other is reduced to the phenyl methanol. This reaction is very old, but it has certain disadvantages or non-green context, which sometimes they ask that what is the problem with the conventional Cannizzaro reaction. Strong basic condition is required. So at the end of the reaction, you have to neutralize the reaction medium with an acid. So that involves using a strong acid to neutralize the strong base. That is, if we can, we have to avoid that step. The desired products are obtained not in a very good yield. Sometimes the yields are very low. Heating is usually carried out in an oil bath, which is a non-efficient, non-renewable energy source. Reactions are normally carried out in solution phase, which may involve organic solvents, and that means the disposal of the residual solvent creates an environmental impact. Separation of the products is not so easy. So we have to do these reactions, improve the yield, reduce reaction time, possibly make the isolation of the products easier. If we can achieve those things by modifying the reaction condition, by introducing some green concepts, then that would be great. ঠিক আছে, পরিষ্কার বোঝা গেছে? Any problems? Do you have any questions?
No, sir.
আচ্ছা, আমি একটা প্রশ্ন করি, ডু ইউ, হ্যাঁ বলো।
স্যার বলছিলাম যে গ্রেন রিঅ্যাকশন ক্ষেত্রে কোশ্চেনগুলো মানে মেকানিজম কি কিছু দিতে হবে নাকি নরমালি দেখা?
আই ডোন্ট থিঙ্ক যে মেকানিজম চায়, কিন্তু আমি এই কোশ্চেনটাই তোমাকে করতে যাচ্ছিলাম ইনফ্যাক্ট, যে ডু ইউ অ্যাকচুয়ালি রিমেম্বার দ্য মেকানিজম অফ ক্যানিজারো? তোমার মনে আছে তো?
হ্যাঁ স্যার, এবার মনে আছে। হ্যাঁ স্যার,
একবার কি করে দেখিয়ে দেবো? মনে আছে, ঠিক আছে, ওকে। সো লেট আস টেক the prototypical example of Cannizzaro, যেটা সবাই করে থাকে, বেঞ্জালডিহাইড, রাইট? তো এর মধ্যে অ্যালকালি দিচ্ছে, রাইট? দিলে কি হবে? ফার্স্টে কি হবে বলো দেখি, ফার্স্টে কি হবে?
হাইড্রোজেনটাকে,
কোন হাইড্রোজেন? হাইড্রোজেন কি করবে? ওই হাইড্রোজেনকে তো খাবে না, nucleophilic attack হবে। হ্যাঁ, OH minus will act as either as a base or as a nucleophile. There is no proton to abstract, therefore it will act as a nucleophile. ও বেস হিসেবে কাজ করতে পারছে না, তাহলে the best thing it can do is to attack as a base, right? তাহলে এটা হয়ে গেল, I have hydrogen and I also have a minus, right? Okay, fine. তারপর কি হবে?
OH হবে না, OH হবে না,
OH হবে, sorry, yes, OH, sure, yeah. তারপর কি হবে? Carbon oxygen double bond formation is easy or favorable. It wants to reform the carbon oxygen double bond, provided it can make something go away. Generally H minus is a very bad leaving group, pH minus is a really bad leaving group, but this time you have a sink where you can deposit the H minus. H minus take you can deposit there, and if you deposit the H minus there, then this will become এটা কি তৈরি হলো? বেনজোইক অ্যাসিড। আর এইটার কি হলো? এই যে এইটা, ধরো এটাকে নীল রং করে দিই। লেটস কালার দিস ব্লু অ্যান্ড লেটস কালার দিস রেড। তো রেড ইজ দ্য hydride donor. The hydride donor itself gets oxidized and the blue benzaldehyde molecule is accepting a hydride, so it will be কি হবে? Reduced হয়ে যাবে না? So this will become like this. And surely this will be like minus here. এবার কি হবে? স্ট্রং অ্যাসিড আছে, স্ট্রং বেস আছে, অ্যাসিড বেস রিঅ্যাকশন হবে, প্রোটন এক্সচেঞ্জ হবে, শিওর। অ্যান্ড দেয়ারফর উই উইল ইভেনচুয়ালি এন্ড আপ উইথ যেটা স্ট্যানিস্লাও ক্যানিজারো পেয়েছিলেন, সেটা হচ্ছে একটা বেনজোয়েট, অ্যান্ড উই আর গোয়িং টু এন্ড আপ উইথ আ বেনজাইল অ্যালকোহল, রাইট? এর একটা ইয়ে ভার্সন হয় না, এটা তো নর্মাল ক্যানিজারো, আর একটা ক্রসড ক্যানিজারো বলে একটা বস্তু হয় না, মনে আছে? ক্রস ক্যানিজারোতে জেনারেলি আমরা একটা জিনিসকে ব্যবহার করি, সেটা হচ্ছে ফর্মালডিহাইড, অ্যান্ড ইট ইজ দি ফর্মালডিহাইড হুইচ ইজ অ্যাকচুয়ালি অলওয়েজ অ্যাক্টস অ্যাজ দ্য হাইড্রাইড ডোনার। দেয়ারফর ফর্মালডিহাইড এবং বেঞ্জালডিহাইড বা যে কোনো অ্যারোমেটিক অ্যালডিহাইড মিশিয়ে যদি রিয়াকশন করো, দ্যাট অ্যারোমেটিক অ্যালডিহাইড উইল বিকাম the corresponding primary alcohol. Say for example with benzaldehyde you will get PHCH2OH, and formaldehyde will always act as a hydride donor and itself gets oxidized to formate. Can you tell me why is it more likely to for formaldehyde to act as a hydride donor? If I revise this thing like this way, if I can revise this whole scheme like this, everything here can be replaced by a hydrogen. So that's hydrogen, that's cross Cannizzaro, no?
Yes, sir.
Can you tell me, do you remember why formaldehyde is the one, why this one is the one which always gets oxidized? Let me ask you one question. In which form formaldehyde exists in water, do you think? Does formaldehyde exist in this way or some other form is present? In water, because this is a reaction which is done in water.
Normally it's the nucleophilic attack হয়ে যাবে।
Yeah, sure. Water will make nucleophilic attack, and therefore formaldehyde is most likely to exist in this form. And in fact formaldehyde exists actually in this form in water, right?
Yes, sir.
And if you look up the chemical literature where pKa values of different organic compounds are tabulated, it is extremely baffling to someone who is new in organic chemistry to find out that the pKa value of formaldehyde is tabulated is 12. Does it make any sense? How can this hydrogen have a pKa value of 12? I mean, if this hydrogen had a pKa value of 12, then generating this anion would have been really easy, is it not? এটা তৈরি করাটা ইজি হতো না ভীষণ? তাহলে কি আর ওই ডাইথায়েন দিয়ে কোরেসিভাক রিএজেন্টের কোনো কনসেপ্ট ডেভেলপ করার দরকার পড়তো? কারণ তুমি তো অ্যাসাইলিয়াম আয়নই তৈরি করো বেসিক্যালি, কার্বনিলের মাথায় মাইনাস। তো ফর্মালডিহাইডের হাইড্রোজেনকে ইফ ইউ ক্যান অ্যাবস্ট্রাক্ট ফর্মালডিহাইড হাইড্রোজেন সো ইজিলি বিকজ দ্য পিকে ভ্যালু ইজ রিপোর্টেড সাপোজেডলি 12, then you wouldn't have needed any dithion protection and then abstraction of the hydrogen by lithium or organolithium and then reacting with the electrophile and then removing the sulfur groups by mercury, etc. Core and Sivak's reagent would have been redundant. Actually, the pKa value 12 is reported in water, and in water formaldehyde exists in this form. If formaldehyde exists in this form and you add some alkali to it, then it will become something like this for surely. And this is the hydride donor that you have in the reaction medium. This is the hydride donor, and it is also statistically more favorable because how many hydrogens is present there which can be donated? How many? It will be donated, one hydrogen will be donated, but how many potential hydrogen do you have that can be donated? 2, na? And if benzaldehyde is acting as a hydride donor, how many hydrogens does it have? So which one is statistically more likely to act as a hydride donor? Formaldehyde. And you don't even need the first nucleophilic attack. You don't even need this part. You don't need that part because formaldehyde is already in this form. All it takes is just abstraction of the proton, and it is quite easy because the pKa value is only 12. The pKa value of water is 14. Therefore, hydroxide will very gladly accept a proton from the formaldehyde hydrate. Formaldehyde hydrate will very gladly give up one hydride because it generates a formic acid which readily undergoes deprotonation under this alkaline medium and generates a resonance stabilized formate ion. And by the time you look, formaldehyde has donated its hydride, the other aromatic aldehyde has gladly accepted the hydride and itself has got reduced. মনে পড়েছে? মনে পড়েছে না পড়েনি? সো ক্যানিজারো রিয়াকশানে এরকম সব জিনিসপত্র দিত, দেখো তো, মনে করে দেখো তো, দেখো এগুলো সব হচ্ছে কোন ক্লাসের জিনিস এগুলো? কোন সেমিস্টারে পড়েছিলে? সেমিস্টার 3 না? ঠিক, হ্যাঁ ঠিক মনে পড়েছে। এ দেখো ফিনাইল আর হাইড্রোজেন, ইন্ট্রামলিকুলার ক্যানিজারো, তাই না? তাহলে এবার এর ওপর যদি তুমি ওই ক্যানিজারো দিয়ে করতে যাও তাহলে কি হবে বলো তো? অ্যালডিহাইড আছে আর একদিকে কিটোন আছে, তো অ্যালডিহাইডের ওপর নিউক্লিওফিলিক অ্যাটাক হবে ফর শিওরলি। অ্যালডিহাইডের ওপর যদি নিউক্লিওফিলিক অ্যাটাক হয় তাহলে ডেফিনেটলি ওটা হাইড্রাইড ডোনার হিসেবে কাজ করবে। তার মানে এই জায়গাটা হয়ে যাবে তোমার OH, এইখানটা হয়ে যাবে হাইড্রোজেন, এ দেখো রিডিউসড হয়ে গেছে। আর এই পার্টটা কী হবে? এটা হয়ে যাবে না? হ্যাঁ, কারণ OH তো থাকতে পারে না। প্রথমে OH মাইনাস অ্যাটাক করেছিল, তারপর O মাইনাস হয়েছে, O মাইনাস পুশ ব্যাক করেছে, হাইড্রাইড ডোনেট করেছে, দিস থিং হ্যাজ বিকাম লাইক দিস। ওকে, বলো তো সেমিস্টার 4-এ কোন রিয়াকশান তুমি পড়েছিলে যার সাথে এর মেকানিস্টিক সিমিলারিটি আছে? বলো দেখি। আজকে এই ক্লাসের শুরুতে আমি সেই রিয়াকশানটার কথা বলেছি। ভাবো, রিঅ্যারেঞ্জমেন্ট রিয়াকশান পড়ার সময় পড়েছিলে, তা বলে দিলাম। মাইগ্রেশন ফ্রম কার্বন টু ইলেকট্রন ডেফিসিয়েন্ট কার্বন, এটাও বলে দিলাম। হচ্ছে না? Nope. Nope. Look at this. Look at this one. কি রিয়াকশন এটা? এটা পাচ্ছ না? এই কম্পাউন্ডের নাম কি? বেনজিডিন সেমিডিন কোথা থেকে এলো? সে তো নাইট্রোজেন। বেনজিল। Did I not talk about that in today's class? I talked about it, no? Salt of benzylic acid. Benzyl, right? So you see, everything is actually connected. In organic chemistry, this connection is very important, as I have told you. And as I have learned from my esteemed teachers, that you can't really learn semester 5 organic chemistry by neglecting semester 2, 3, 4. Or for that matter, when you were discussing green chemistry reactions, if you don't have a clear idea about the mechanism of the reaction or what is going on, then it probably becomes sometimes tedious to memorize all these things. So let's see how a green Cannizzaro reaction is done. The very common reaction which you can do in your own laboratory, if we could supply you with the requisite aldehyde, and this is something which is practiced all over the world. In solid phase reaction, you have done benzylic acid, but we could have done this thing. We could have done this experiment in our laboratory. It is so simple. An example of green Cannizzaro reaction which avoids the use of solvent and the reaction consequently takes place in solid phase, where we have used orthochlorobenzaldehyde as the substrate. You take liquid orthochloro or 2-chlorobenzaldehyde and then you mix it with potassium hydroxide pellets, and then what you do, you take them in a mortar and you grind them in a pestle for about 30 minutes. So obviously this is not going to be a pleasant thing to be doing, but if you can persevere for 30 minutes, if you press so that this becomes a sort of a paste, from this paste you can isolate the 2-chlorobenzyl alcohol and the water soluble potassium salt of the 2-chlorobenzoic acid by simple water treatment. So this is a paste, right? This is a paste where you have the potassium salt of the 2-chlorobenzoic acid and you also have the corresponding alcohol. Out of these two, which one do you think will be more soluble in water? Out of these two, which one do you think will be more soluble in water? Which one? Which one is the salt?
Salt ওই K plus
हाँ, benzoate, 2-chlorobenzoate obviously. So it will be soluble in water, and this thing will not be soluble in water. Let me ask you this question now. This bolo.
second compound hydrogen bonding করে পারবে না soluble হতে?
To some extent probably yes, but it is also does not stand any chance with respect to the salt that is there. So if you remember the benzylic acid solid phase reaction, if you remember in your CEM 2 where you did the practical yourself, the instruction after the heating for maybe 1 hour, you were supposed to add minimum volume of water into the mixture, right? Minimum volume of water. So here also you will be adding just the amount of water which is sufficient to solubilize the potassium salt. If you use maybe excess water, then the chlorobenzyl alcohol may be soluble. Understood?
Yes, sir.
And then you have the filtrate and you have the residue. The filtrate itself, if you acidify it from the potassium salt, you will get the corresponding carboxylic acid. This is a practical which we can do in our laboratory, and people do that. This is a very standardized experiment done all over the world to demonstrate the power of solid phase reactions. 2-chlorobenzaldehyde, I suppose it will be a little bit of expensive, but it can be done. If things can be arranged, it can be done. So what is the green context? Can you tell me the green context? So it's a solid phase reaction. Obviously no environmentally toxic solvents were used. Extraction is very easy. How do you extract? Just treat it with a minimum volume of water, shake it, filter, filtrate by acidifying with little bit of HCl, you get the corresponding carboxylic acid, and from the residue you will get the corresponding alcohol. The reaction time is relatively short. 30 minutes may look like a long time for grinding, but if this reaction is done in liquid phase, then adding up to the chromatographic separation and etc., it may take hours on end. So you are saving a lot of time there as well. Okay. So next up is microwave assisted Cannizzaro. Just as Aldol reactions are done in microwave environment, microwave assisted Cannizzaro also were studied, and fully reproducible Cannizzaro reactions under microwave assistance has been established. Conversion of aldehydes to their corresponding carboxylic acids and alcohols. Here we have given example of one particular molecule which you should remember. What is this molecule? Can you tell me the name of this molecule? Farfural, no? Furan 2 carbaldehyde. In your heterocyclic course, you encountered this compound. One particular question comes to mind that they used to ask you, that farfural takes part in Cannizzaro reaction, but but pyridine 2 pyrrole 2 carbaldehyde does not. Remember that question? Do you remember that question? Farfural responds to Cannizzaro reaction, but pyrrole 2 carbaldehyde does not. What is the answer of that question? Can somebody tell? What's so special about farfural and what's so not so special about the corresponding ASA analog? So this one is like NH, no? So this one undergoes Cannizzaro, this one does not undergo Cannizzaro. Why? See this hydrogen? Is this hydrogen acidic or not? This hydrogen is pretty acidic. Actually, for pyrrole, its value is pK value is like around about 17, and this one, because it has a electron withdrawing group right next to the nitrogen, it can stabilize the negative charge. The pK value, I would expect the pK value to further go down, and if that happens, see what is happening here. This nitrogen, this lone pair can delocalize itself onto the carbonyl, and therefore the electrophilicity of this carbonyl, what is happening here?
Reduce electricity.
Yeah, sure, and that's exactly what you need for Cannizzaro, no? Cannizzaro reaction requires that you make a nucleophilic attack with hydroxide onto the carbonyl carbon first. It's not so easy here. And if I highlight this part, say if I highlight this part, if I go on highlighting this part like this, and this is something which I have learned from my teacher, CS sir. Do you see that this is basically an amide, a vinylogous amide, right?
Sir.
What is this then? If this is a vinylogous amide, what is this one? এটা কি? Nitrogen থাকলে amide বলে, oxygen থাকলে কি বলে? Why should you call it oxime? It's an ester, no? Vinylogous ester. Oxime হতে গেলে তো you need NO bond. Where is the NO bond here? It's an ester, no? So that's a vinylogous ester. এবার ester এবং amide এর মধ্যে কোনটা মোর নিউক্লিওফিলিক? কোনটা মোর ইলেকট্রোফিলিক? Obviously, oxygen does not want to donate electron as happily as nitrogen does, because nitrogen is by default less electronegative, happy to share its electrons, and that's why ester is more electrophilic, and therefore that also kind of corroborates the fact that furfural, being a vinylogous aldehyde, I mean vinylogous ester, and half aldehyde half ester kind of thing, should be more reactive, more amenable towards nucleophilic attack, and therefore it happily undergoes the Cannizzaro reaction. Whereas the corresponding nitrogen analog, you can consider it as a vinylogous amide, therefore you should be right at that moment, you should be circumspect that whether the Cannizzaro reaction would be good for it, because that will require the nucleophilic attack, and nucleophilic attack is probably not going to happen here. And secondly, in the basic medium, in the strongly basic medium that you are using for Cannizzaro reaction, the hydrogen that is present on nitrogen will be abstracted, and as a result this thing will be further demotivated to accommodate an incoming nucleophile. Clear or not?
Yes, sir.
So they have done this thing with furfural, you can do this thing with pyridine carboxyldehyde or any aromatic aldehydes or thiophene 2 carbaldehyde. See, there is no pyrrole 2 carbaldehyde present here. Under mild condition there is no pyrrole 2 carbaldehyde, whereas 1-methyl pyrrole 2 carboxyldehyde derivatives and aliphatic aldehydes require more drastic conditions. Do you understand why? Pyrrole 2 carbaldehyde is less reactive, therefore you need to put in a lot of more energy, and therefore drastic reaction conditions. Okay,
Yes, sir.
are you getting these things, or মানে সব ট্যান হয়ে বেরিয়ে যাচ্ছে মাথার উপর দিয়ে? See an example of a cross Cannizzaro. See, we told you about this, no? What is happening to the formaldehyde? What is happening? It is getting oxidized. And what is happening to the aromatic aldehyde? It is getting reduced. We all already talked about this, that formaldehyde, when you have formaldehyde in the reaction medium, that is the hydride donor. It will listen to nobody else, it will just give up its hydride and become formate. That's it. So they have done this reaction with barium hydroxide 8H2O catalyst, and in microwave irradiation condition, and look at the time, just look at it, within 30 seconds your reaction is done. So that's got to be really appealing for a synthetic organic chemist who can save hours and hours of his labor or her labor in front of the bench just by purchasing a microwave reactor where he or she can do all these reactions. So while he was able to do maybe 3 reactions in a day, he could do 3 reactions in under 10 minutes. So that gives him or her the huge scope of exploring the vast array of substrates that may be available to him or her. So that's good. That is definitely good. Where did it go? And so look at the green context. Presence of mild base under solvent-free condition. The main problem was we were using like very strong base, so that was one environmental concern. We were using solvents which were environmentally destructive, so we have avoided both problems. Reaction takes place under microwave irradiation, which is a renewable energy source and a green energy source. Very very short time and gives excellent yield with remarkable selectivity. I don't think that any of you will have any problems in outlining the green context of any reactions, because the same themes are coming and harping themselves on. What can be a challenge though is to find out or at least remember some of these reactions. But as I have bolo
এই রিঅ্যাকশন যে আপনি পরে যেগুলো দেখালেন এটার সাথে ওই মেইন রিঅ্যাকশন মেকানিজমটাও আসতে পারে, তাই তো? এই
I don't think so. Mechanism দেয় না কখনো. Just consult, because I have already shared with you the last 3 question papers that was set in our university. মেকানিজম দিয়ে কোশ্চেন বোধহয় আসে না। আমি মেকানিজমগুলো করাচ্ছি কেন? বিকজ আই ওয়ান্ট ইউ টু ব্রাশ আপ অন ইউর অর্গানিক কেমিস্ট্রি, বেসিক অর্গানিক কেমিস্ট্রি a little bit as we move along, because you don't have any core organic chemistry course in this semester, right? অথচ you will probably have to answer 1/3 of your competitive exams, which will be 1/3 will be based on organic chemistry. So if you are completely detached from organic throughout the semester, then after the completion of the course, any sort of competitive exam may pose a significant challenge to you. সেই জন্য আমি এটা মনে করিয়ে দিচ্ছি তোমাকে, অ্যান্ড ইটস ভেরি পসিবল বিকজ অ্যাজ আই হ্যাভ টোল্ড ইউ, organic chemistry is like a chain which is linked, one concept is linked to the other, however further along the chain that concept might be. So if you rattle the whole chain, everything rattles, and if you listen to that with that thing in mind, that this is a chain of logic which goes through all the concepts, then it's music to you. And if you have like no idea that one concept is related to the other is related to the third other, and then it becomes a completely cacophony. It's not music, it's just cacophony, just noise. So that's why আমি করছি, এটা পরীক্ষায় আসবে বলে করছি বলে ধরে নিও না, okay? Ultrasound assisted Cannizzaro reaction, we have already talked about acoustic cavitation and the effect of sonication, where sonic boom inside a solvent medium is utilized to carry out several organic reactions. Cannizzaro reactions can also be carried out in this way. Here is one example where benzaldehyde is sonicated in presence of barium hydroxide base, and in ethanol medium the reaction takes only 10 minutes, and look at the yield, 100% yield. And if you mix benzaldehyde in ethanol in barium hydroxide at say room temperature, you keep it for 10 minutes, nothing will happen. So on one side you have 100% reactions with the intervention of sonication, and on the other side you have like zero yield without the application of the ultrasound machine. So that's better, because you are saving a lot of time, the yield is very high, very mild base is being used, and ethanol is also considered a green solvent. Why ethanol is considered a green solvent, we will talk about that later. And the reaction takes place under ultrasound, so it's a renewable energy source, excellent yield, and very short reaction time. So all these things are in favor of this thing, the favor of the Cannizzaro reaction being carried out in ultrasound. So they might ask you to give you this example where they want you to write down an example of a Cannizzaro reaction under green condition. So you can use the microwave example, you can use the solid phase example, you can use the ultrasound example, and then they will ask you that highlight the green concepts that are absent in the conventional Cannizzaro procedure. These sort of questions they generally ask. The next up we have Novenagel condensation, but as our time has run out today, we will not be venturing into that. We will be talking about this thing in the next class. Novenagel condensation is basically an offshoot of Aldol condensation. So anybody who understands Aldol should have like very little difficulty in understanding the Novenagel, but we will talk about that later. Do you have any questions from today's discussions? If you have any questions, you can ask. No questions? So I am stopping the recording.